Now, this doesn't mean we've solved the antimatter mystery, not yet, but it gives us a new direction. A new class of particles where the differences between matter and antimatter might be stronger. And if those differences scale up, even just slightly over time, they could explain why matter survived the early universe, while antimatter didn't. It's one of those moments in physics where the door doesn't swing wide open, but it does crack just enough for new light to come through. And suddenly people are paying attention again. Because if baryons like the lambda B behave differently from their antimatter twins, then maybe protons and antiprotons do too. Maybe the fundamental stuff we're made of isn't as symmetric as we thought. And maybe that's the key to the universe we live in now. But that's just one mystery. Because while the LHC is looking at high energy collisions, something even stranger is happening in another part of CERN, where scientists are trying to do the unthinkable: put antimatter in a truck. You probably don't think of antimatter as something you can just load onto a truck and drive across town. But that's exactly what CERN is working toward. For the first time in history, scientists successfully moved a cloud of protons, stand-ins for antiprotons, across the CERN campus using a specialized mobile trap. They built a high-tech box to safely contain these charged particles and drove it about 4 kilometers across the facility, proving they could one day transport actual antimatter the same way. Why is that such a big deal? Because antimatter isn't just rare, it's absurdly difficult to handle. The moment antimatter touches regular matter, it annihilates. Gone. Massive energy release. So you can't put it in a glass jar, you can't freeze it or shove it into a metal tank. It has to be suspended, levitated, really, inside magnetic fields, inside a vacuum, inside a carefully engineered trap. It's like trying to carry a drop of pure sunlight in your hand without getting burned. So why take that risk? The reason is precision. While CERN's antiproton decelerator is great for generating and studying antimatter, the facility is surrounded by large magnetic fields from nearby accelerators and instruments. And those fields can subtly interfere with the delicate measurements scientists want to make. So, researchers developed a way to transport these charged particles to a quieter, more controlled lab environment, specifically to a facility in Germany with better shielding and less magnetic noise. That's what this mobile antimatter trap was for.